Ladies and gentlemen, welcome to Algebra 1. Sorry I've been gone for a few days this week, guys. Yesterday, I had one kid with a fever of 101. By midday, I had two kids with a fever of 101, so I had to have two kids home. I was trying to be super dad and take care of them without getting sick myself. My wife had the fever on Sunday, my daughter had it on Monday, my son has it on Tuesday. I refuse to get it, so I'll be back on Thursday. I'm going to put my money on it here, guys. You're going to see me. I know you guys miss me, and you miss doing algebra with me. So, but I still want to keep you guys kind of moving forward here, so I'm going to try to do a lesson here. Hopefully you brought your computers, or you can share them at least and walk through these. This should probably be pretty easy. I just looked over the paper you guys did yesterday on Tuesday, and most of you did a pretty good idea how to solve equations. It's not the same thing we were talking about on Monday, and I will come back when I'm there to kind of revisit that and finish that topic up. So don't lose that paper for Monday. And the title on your paper says 3.2. In the book, it's section 3.2. We're probably going to scribble that out and call that like 2.3 because you know what we're doing is sort of our second unit. So don't worry about changing it right now. Definitely get a title on your paper, Solving Multi-Step Equations. You did a couple of these yesterday on that worksheet. I'm going to walk you through just a couple of these. This might be pretty quick, might be pretty easy. If you're good at it, solve them on your own. Make sure you're showing your work. It is required. It is the expectation. You're getting points based on the work shown on here. So whether it's on the notes or homework or even on the quizzes and tests. A lot of times we're looking for specific steps shown in there somewhere. So you'll also see something else I did here. You don't have to do this, but I'm often going to put a big dividing line where the equation is, where the equal sign is. In other words, it's the idea that whatever's on the left side has to be balanced with on the right, and I've got to put that right down the middle. Whatever you do to the left side, you've got to also do to the right side. We're essentially doing, it's kind of weird we learned PEMDAS in Unit 1, because solving an equation is the exact opposite. You do everything sort of in reverse order. There's parentheses, you do exponents. If there were exponents in this problem, you would deal with the exponents last in terms of isolating a variable. And of course, isolate, there's a couple blanks on your paper defining that. Isolate means to get something by itself. You know, you're trying to undo two different things. You're trying to undo this subtraction, and you're trying to undo this division. So I wouldn't do this in two steps. And you do it in reverse PEMDAS. So you always do your addition subtraction first, and you do your multiplication division second. And then if there's an exponent, you would take a square root or take a cubed root, which we'll do that later in the year. Don't worry about that right now. We're going to stick with linear equations, which means no exponents for a little while. So most of you know you're going to add 4 to both sides. This is sort of the way I want to see it shown. You might have seen in a previous class you did work laterally across the page. I want you to work vertically. So we can see step 1 is the given. Step 2 is you're adding 4 to both sides. Step 3, what are you going to do? Oh, you're going to divide the 2 out of there. Be careful with your addition here. It's actually subtraction. And of course the whole concept of this is things cancel out. I do opposites. I see negative 4, I'm going to do the opposite and add 4. Should end up with something like that. 2x is equal to negative 14. Again, everything's lined up here sort of in columns, so it's organized. Divide the 2 on both sides. I like to show that with a little division bar, a fraction bar. 14 divided by 2 is 7, and of course it's got to be negative because the 14 was negative on there. One of the two numbers was negative. Like I said, you can work ahead, but definitely, you know, take a look and double check these as you go. Second one, you know, you don't have to do it in this order. You could subtract 16 on both sides first. But oftentimes if you see like terms, combine them. So 8x minus 5x is 3x. It just allows you to have less things to look at. So now you've only got 1, 2, 3 items to be concerned with as opposed to 1, 2, 3, 4 terms on there. Hopefully you're thinking subtract the 16 on both sides, with the idea being these cancel out, and you're isolating the variable. You get less and less things on the variable's side of the equation. 16 and 29, they're both negative. Add them and keep the sign of the bigger one. So that's like, what, 45? And of course it's negative on there. And then the last thing is to get rid of that 3. 3x means 3 times x. The opposite of multiplying by 3 is dividing by 3. So a little division step on there. And again, you get a negative on this one here. Negative 15, because one of the numbers was negative. And sometimes you'll see me show it that way. The 3 divided by 3 cancels out. 16 minus 16 cancels out. So the whole idea of solving an equation is doing opposites of what you see. The opposite of adding 16, the opposite of multiplying by 3, to get the variable isolated. Like I said, you don't have to draw that line in here, but I'm doing that just so you understand that this is the middle of the problem is over here. Whatever you do on the left side of that, you have to do on the right side to keep an equation balanced, the concept of balance and equality. Maybe do these on your own and then look up and double check to see if you got the correct answer. You might do them in a different order, which is perfectly okay. As long as you get, you have the same solution and your solution works if you plug it back in and check it. Hopefully you're thinking add 5 to both sides. You get 2x equals 14. Divide both sides by 2. And you get 7 for that first one. The second one, addition subtraction always comes first, so hopefully you're subtracting 3. And what I'll often see people lose is this little minus sign. They'll detach that from the problem and pretend it's not there. That's important. The 4 is negative, which means you're not going to divide by 4 here. You're actually going to divide by negative 4. So this entire thing cancels. If you didn't do that, the negative sign wouldn't cancel, and it wouldn't actually be, you wouldn't be done. 16 divided by negative 4 is negative 4. The problem with the m's. Probably combine like terms first. So you get 8m plus 3 equals negative 29. Subtract the negative 3 to get rid of that. 8m is equal to negative 32. And then the division step, divide both sides by 8. And hopefully get negative 4. 35 is on the left side. All this other garbage is on the right. Again, one you can combine. If you see them on the same side of an equation, you can combine them. So you should be able to combine those and get 20y. Add the 5 to both sides and things get nice and easy. 20 goes into 40 2 times. So 20 times 2 got to equal 40. Y must be 2. And again, I'm showing it as a division step on there with the fraction. Oh, if you couldn't see it, those are those bottom two answers. All right, I'm going to go on a second part on the next one. You're certainly welcome to try number 3 on your own if you think you know how to do it. I'm going to put that in the second part, so tune back into that section here. If this video gets too long, it gets cut off here and I lose reception. So I'll be back in a moment. Look for the next section. It should show up in your YouTube.